Welcome to the DIY Honda Garage channel. The DTC P2A00 indicates an issue with the air-fuel AF sensor circuit, specifically referred to as Sensor 1. This sensor plays a crucial role in monitoring the oxygen concentration in the exhaust gases, which is essential for the engine control module's PCM ability to manage engine performance efficiently. When the AF sensor detects an output voltage that is significantly off compared to normal levels, particularly during deceleration, it alerts the PCM, triggering this diagnostic trouble code. The abnormal readings can signal that the engine is not operating optimally, which can lead to increased emissions and reduced fuel economy. It's crucial to address this problem promptly to maintain the vehicle's performance and compliance with environmental standards. The following slides will provide an in-depth look at the components involved, possible causes, symptoms, and a step-by-step troubleshooting guide for resolving this error code. The A-fuel sensor, specifically Sensor 1, is vital for determining the oxygen levels in the exhaust stream. This sensor is typically located in the exhaust manifold or upstream of the catalytic converter, where it can efficiently measure the exhaust gases as they exit the engine. It works by generating a voltage signal that correlates to the amount of oxygen present, which the PCM uses to adjust the air-fuel mixture for optimal combustion. An accurate reading from the A-fuel sensor is crucial for maintaining engine efficiency and emissions compliance. If the sensor's output deviates significantly during deceleration, it indicates a malfunction, prompting the PCM to store the DTC P2A00. Identifying the exact location and function of Sensor 1 is essential before proceeding with any diagnostics or repairs. There are a few potential causes behind the DTC P2A00. The first and most common is a faulty AF sensor, as the sensor can wear out or malfunction over time due to exposure to harsh exhaust gases. Wiring damage can also contribute to the issue. If the sensor's wiring is frayed, shorted, or corroded, this could lead to inaccurate readings. Another potential cause is a malfunctioning PCM, the engine control module responsible for interpreting sensor readings and managing engine operation. Each of these scenarios emphasizes the need for careful examination and testing during the troubleshooting process to ensure that the exact cause of the DTC P2A00 is identified and rectified effectively. When experiencing the DTC P2A00, vehicle owners may notice several alarming symptoms. The check engine light will typically illuminate, serving as a primary indicator of a problem detected by the PCM. Additionally, a noticeable drop in fuel economy could occur, as the engine may not be receiving the correct air-fuel mixture due to the sensor's inaccurate readings. Drivers may also experience a loss of power during acceleration, making the vehicle less responsive and potentially unsafe. Other symptoms may include rough idling or stalling, which are indicative of further engine performance issues. Being aware of these symptoms up front allows for quicker diagnosis and maintenance, ultimately leading to safer and more efficient driving. In the first troubleshooting step, begin by starting the engine to initiate the diagnostic process. Allow the engine to reach a stable operation before proceeding. Once the engine is running, hold the engine speed at 3,000 revolutions per minute, RPM, without any load by keeping the transmission in park or neutral. This stabilized running condition promotes optimal performance and ensures that the PCM can accurately assess sensor outputs. As you maintain this speed, watch for the operation of the radiator fan, which is a sign that the engine is reaching temperatures that warrant cooling. This step sets the baseline for evaluating the AF sensor's performance during subsequent diagnostic assessments. After holding the engine at 3,000 RPM, let it idle to prepare for the test drive. During idling, monitor the engine coolant temperature (ECT) sensors readings from the Honda Diagnostic System (HDS). It's essential that the ECT sensor 1 registers a temperature above 158 degrees Fahrenheit, 70 degrees Celsius before proceeding, as this temperature indicates that the engine is operating within a suitable range for testing. This step affirms that the engine's condition is adequate for accurate sensor evaluation during the driving conditions stipulated in the next step. Once you ensure the appropriate ECT reading, the vehicle is ready for a more thorough test drive to evaluate the AFAC sensor performance. Now, commence the test drive following the specific conditions for this diagnostic process. Drive the vehicle at a speed between 25 to 55 miles per hour, 40 to 90 kilometers per hour, for at least 5 minutes to allow the PCM to collect data about sensor performance during moderate driving. After maintaining that speed, accelerate to a steady pace of 55 to 75 miles per hour, 90 to 120 kilometers per hour, for a minimum of 10 seconds. Following this, fully close the throttle to decelerate for 5 seconds or more. This sequence enables the PCM to observe the AF sensor's performance and voltage output under varied engine loads and speeds, which is crucial to confirm any abnormalities related to the DTC P2A00. Accurate adherence to these driving conditions is vital for effective diagnostics. Finally, after completing the test drive, use the Honda Diagnostics System (HDS) to monitor for the DTC P2A00, examining the onboard diagnostics (OBD) status for any recorded abnormalities. This component of diagnostics allows for comprehensive analysis by displaying the current conditions related to the A/F sensor's performance in relation to the engine's operation. If you observe the P2A00 code during this monitoring phase, it reinforces the need to look deeper into the sensor and related circuits. If the DTC is not present, that may indicate that the problem was transient or that it has been resolved through the diagnostic process thus far. Detailed observation at this point informs the next steps for repairs and ensures any underlying issues are addressed adequately. Once repairs are undertaken, it is essential to verify their effectiveness thoroughly. Inspect the newly installed AF sensor to ensure it is functioning optimally by checking its connections and validating the readings it provides to the PCM. This validation might involve executing the earlier diagnostic steps to confirm that the DTC P2A00 no longer appears. Following this, it's crucial to clear any DTCs from the system using the HDS, ensuring that previous fault codes do not influence ongoing diagnostics or the vehicle's emissions assessment. This final verification provides peace of mind that the vehicle is back to its expected operating condition and compliant with performance standards. Proper verification is a vital step in any repair process, confirming that all issues have been effectively resolved. Preventive maintenance is critical to avoiding future occurrences of the DTC P2A00. Regularly checking the AF sensor's performance and its electrical connections can preemptively catch issues before they escalate. Monitoring overall engine performance, including fuel consumption and responsiveness, is also beneficial. Any irregularities might be early indicators of sensor or engine issues. Additionally, maintaining the exhaust system contributes to ensuring that exhaust gases are appropriately processed, which supports the sensor's role. Addressing issues such as leaks or blockages promptly protects the AF sensor and the PCM from receiving faulty information. Adopting these preventive measures supports the longevity and reliability of your Honda CR-V's engine system. In conclusion, Understanding the DTC P2A00 and the role of the AF sensor is vital for maintaining proper engine function in the Honda CR-V. This diagnostic trouble code indicates that the AF sensor may be malfunctioning, leading to issues such as poor fuel economy and engine performance. Timely troubleshooting is essential for accurately diagnosing the source of the problem and implementing the necessary repairs, avoiding further complications down the line. The troubleshooting steps outlined provide a clear framework for addressing the DTC P2A00 comprehensively. Lastly, adopting preventive maintenance strategies will ensure the longevity of the AF sensor and overall engine performance, contributing to improved efficiency and compliance with regulations. Regular monitoring and prompt attention to any warning signs will keep your Honda CR-V running smoothly. Please like and subscribe to the channel. See you next time.